Hello and welcome to this video on the unit circle. If you are here, then you are trying to turn this into this. Oh, it's so many numbers. It looks very crazy as to how you're supposed to get all of these numbers kind of from memory. You're supposed to memorize it, and it might seem overloading at first, but I swear there are some tips, tricks, and ways to memorize this that in a way doesn't mean you have to literally memorize all of it, every single number and where it goes, because there's a lot of patterns in here that I'm going to be talking about. And I'll be talking about them on this piece of paper as well as making one from scratch. So the first thing I want to talk about, once again, this is you trying to memorize this unit circle. If you have to get a piece of paper and make the whole thing by yourself from memory, that is the goal of this video. Here are some patterns that will help you do that. First of all, the numbers on the outside. If you look at them, you will see that it will be the same numbers over and over and over again, except some are positive and some of them are negative. For instance, this is a 1/2 root 3 over 2. This is also a 1/2 and a root 3 over 2. And this is a root 2 over 2 and a root 2 over 2. Those three numbers are used throughout the entire thing, right? A half, there's a half, there's the root 3 over 2, the root 3's over 2, the root 2's, they're all over this place. And also note that all of these are always over 2. These are over 2, over 2, over 2, over 2, over 2, which means you know for a fact that all of those numbers on the outside, they are all over 2. That is just a fact. So you have now just memorized half of these things because you know for a fact it is a fraction with a 2 on the bottom, which means the only thing that changes is the tops. This is a 1 and a 3, a 2 and a 2, and a 3 and a 1. And notice that they are all square rooted. Technically, it's a square root of 1 as well, but no one cares because the square root of 1 is just 1. But if you want to memorize it that way, you can. It's the square root of either 1, 2, or 3 that's going to be there. But, like I said, it's always going to be 1, 2, or 3, which means if you want to memorize these things, then technically you only have to memorize these things. Boop, 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 boop. And if you can memorize those numbers, you can memorize everything. Why is that? Because root 2 over 2 is always paired with root 2 over 2. It is never the case that root 2 over 2 is not paired with root 2 over 2. And with the 1/2s are always paired with the square root of 3 over 2. Whether it's first or whether it's second, I don't know, I don't care. But they will always be paired to each other. So I'm just going to say out loud these numbers on the top left. 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. And that's all you got to memorize. 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. And if you know that, then you can go here and you can just go 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. And I have filled in those numbers. But remember, they are all over 2. All of them are fractions that are over 2. So I'll just keep going, over 2, over 2, over 2, over 2. But those 2's and 3's need to be square roots, right? Don't need to square root the 1, but the square roots here have to be there. So I'm just going to go ahead, boop, boop. Don't need that one, boop, 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 boop. Like that. And then I'm just going to go through and do the pairs that I'm supposed to. Like all root 2's are supposed to be paired with a root 2. So I'll do that. All root 2's are paired with a root 2. And next up, see if you can anticipate. What's the 1/2 supposed to be paired with? What is 1/2 supposed to be paired with? Root 3 over 2. And the root 3 over 2 is paired with a half. So you go through that. Root 3, opposite will be 1/2. The 1/2, the opposite will be root 3. So again, all of them being over 2. So that's a 1, that should be paired with 3. It's a 3, it should be paired with a 1. 3 paired with a 1. Root 3 over 2. So that gets you all of those numbers right there. Now, technically, in case you haven't noticed, I haven't done these ones up here. That's because that one isn't really, you have to think about it. It's not trig, it's just literally, this is 1, 0. Right? You go over 1 and then it's 0. This would be 0, 1. Right? 0, 1. So I'm not really counting those in the pattern. This would be negative because you're going to the left, so -1, 0. And then 0, -1. So that one's just old school, do you know how to plot points? Not the numbers. But speaking of the positive negatives, I am gonna have to go back and based on the quadrants, fill in positive and negative signs. For instance, in the first quadrant, everything is positive. Boop, 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 everything is positive, good to go. Pause the video and think if you can remember, in the second quadrant over here, which numbers are negative, right? In the second quadrant, which numbers are negative, X, Y, or both? The answer is just the X's, because it's going left in the negative direction and then up in the positive direction. So my X's will be negative and my Y's will be positive. So my X's will be negative, but my Y's stay positive. Same thing, pause the video, see if you remember what's negative in the third quadrant. The answer is everything. Negative, negative, right? Backwards and down. So I'll make all of these negative. And then finally, in the fourth quadrant, positive, negative. So X is positive, Y is negative. So X's are positive, but the Y's are negative. And there you go. Okay. Next up, we have covered everything on the outside. The degrees I'm not going to cover as much. Those are not difficult enough, I guess, to need to. If you do need a hint, then just note that it does count by 30 degrees, not including the big X right here. Actually, I'll use an orange. This right here and that right there. If you ignore these, it just counts by 30. 30, 60, 90, 120, 150, 180, plus 30 is 210, plus 30 is 240, plus 30 is 70, plus 30 is 300, plus 30 is 330, plus 30 is 360, or 0, coterminal. So it counts by 30s. Whereas the big X's, as well as the top ones and bottom ones, those count by 45s. So 45 plus 45 is 90, 90 plus 45 is 135, etc. However, most students I know don't do it that way. They'll just say, hey, what's in the middle of 30 and 60? Well, if these differ by 30, then halfway is gonna be 15, right? 15 goes in the middle of 30. So you just add 15 to get to the next one. You add 15 to get to the next one. All right, add 15. 210 plus 15 is 225. 300 plus 15 is 315. So you can get the degrees that way. So once again, I'm gonna go over here. I'll do this one in the red so it's a little easier. So with degrees, 30, 60, 90, 120, 150, 180, 210, 240. This is 270, 300, 330, 360, And 0, I forgot to put 0. And then for my 45 degrees, remember, it's just 15 more will be there. 15 more would be 135. 15 more would be 225. And 15 more would be 315. With degree signs. I'm not gonna, I didn't write the degree signs, but I should. Okay, there you go. So that's the degrees. So we did all the degrees. Everything that is left is just the radians. So the radians. Pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over blah, 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 blah. It gets kind of overwhelming. But once again, there are some patterns that you can do where all you have to do is then simplify some fractions and it all works out perfectly. Because just like this is counting by 30 degrees, this is still technically counting by pi over 6s. And what I mean by that is this. If you have 1 pi over 6, and then 2 pi over 6, and then 3 pi over 6, and then 4 pi over 6, and then 5 pi over 6, and 7 pi over 6. And do you know what's next? Me going back because I forgot 6 pi over 6, and 8 pi over 6, etc., 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 onwards. You are technically on the unit circle counting by pi over 6s. Need proof? Let's simplify some fractions. 1 pi over 6 is just pi over 6. Well, what is 2 over 6? That reduces. You can simplify 2 over 6. It is, in fact, if you divide them by 2, a 1 pi over 3. And then 3 over 6. How much is 3 over 6? It's 1/2, right? Cross that out, you get a 2, it's pi over 2. 4 over 6 also simplifies. You can divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 5 over 6 does not simplify. 6 over 6, that 6's can just cancel and you get pi. And then you get 7 pi over 6 does not simplify. And 8 over 6 you can divide by 2. If you divide by 2, you'll get 4 and 3. Remember, this is a video, so you can always pause or rewind if you need to go slower. But that is what they are when they simplify. The thing is, if you look at these numbers, they're exactly the numbers that you see on the unit circle. Pi over 6, pi over 4, pi over 3, pi over 2, right? 6, 4, 3, 2. I forgot the 4s. 6, 4 is going to be later, 3, 2. Then you got the 2 over 3, the 5 over 6. Here's the 2 over 3, the 5 over 6, pi. Then there's the 7 over 6 and the 4 over 3, right? The 7 over 6 and the 4 over 3. It is literally just counting by pi over 6s on all the ones that I'm about to do in yellow. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. See, it even says it. 6 pi over 6, 6 pi over 6, right? Simplifies. 7 pi over 6. Hey, look, it even says it. 7 pi over 6, 8 pi over 6, and 8 over 6, right? 8 over 6 simplifies. So 6, 7, 8, 9 pi over 6, of course. 9 over 6, it simplifies. Divide them both by 3, you get 3, you get 2. So 9 over 6, 10 over 6, 11 over 6, ta-da, and then 12 over 6. But 12 over 6 is equal to 2, so it's 2 pi, etc. So what I'm going to do is that on here, right? But I'm going to do it in 2 steps. I'm going to do it unsimplified and then simplified. So here we go. This is 1 pi over 6. This is 2 pi over 6. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 7, 8, 9, 10, 11 pi over 6, and 12 pi over 6. So unsimplified, those are those ones. Once again, I did not do the 45s yet. So if I simplify this, 1 over 6 is just 1 over 6. 2 over 6 simplifies to pi over 3. 3 over 6 simplifies to pi over 2. If I'm going too fast, just pause until it doesn't make sense. 4 over 6 simplifies to 2 pi over 3. 5 over 6 does not simplify. 6 over 6 just becomes pi. 7 pi over 6 does not simplify. 8 over 6 is 4 over 3. 9 is divisible by 3, so you get 3 pi over 2. 10 over 6 is 5 over 3. 11 pi over 6 does not simplify, and this is 2 pi. Okay, as I said, the only thing left is these ones. 45 degrees are pi's over 4. So this is pi over 4. And it is going to go on these dotted lines that I have, as well as the 90-degree ones. These are the 45, every 45 counting by 45s. So this is pi over 4. This would be 2 pi over 4. Just notice that we have already simplified that. 2 over 4 is still the same thing as 1 over 2. So you still get the same number. This would then be 3 over 4. This would be 4 over 4. But same thing is going to happen. So that's 3, that's 4. This is 5 pi over 4. So 4, 5, 6. 7, 8. But just notice that those ones simplified already. All right, 6 over 4, divide them by 2, you get 3 and 2. And 8 over 4 is just 2 again. And that's everything. That was everything we need to do, right? Pretty sure it is. Yeah, it is. Cool. So that is how you can make it from scratch. If any part of this you need reviewing, remember you can always fast forward because it's a video. You can rewind because it's a video. You can even pause. You know why? Because it's a video. And that's a magic pause button that you have when you click your finger on it, or your mouse button, or whatever else you might be using. And there you go. That is a way to memorize the unit circle if your goal is to simply do all of this right here. Okay, there you go. Hopefully that helped. Take care.